All right, so these questions are a little bit different, starting with 6, because you'll notice that there are quantities that are not just accelerations and forces. We're starting to include things like meters per second and time, and that should tell you kinematics. So in a case like number 6, we're going to have to deal with both the dynamics, which we've been talking about, and that's the F net equals ma stuff, and kinematics, which involve the 5 equations. And it's like delta x, delta t, v naught, v, and a. So the thing you can see that links these two things is the a. So we're going to have to keep an eye on what we know and what we don't know, and we might have to use the kinematic quantities to find the dynamics equations or use the dynamics quantities to find the kinematics. It depends on what the problem is asking. So we're just going to have to read the problems carefully, lay it out very carefully, and go from there. So we have a toy car moving across a smooth floor. In the case of a smooth floor, that basically just is telling you don't worry about friction. So here's your floor. You have a toy car moving. So here's your toy car. It's moving across the floor with a velocity of 5 meters per second. So you can see that at the start of this problem, v naught equals 5 meters per second. Then a force is applied to this car, right? A force is applied. It's 2 newtons, and it acts on the car for 4 seconds. So what does that mean? Well, we're going to have to figure out how to put that in. It wants us to know the velocity of the car at the end of the interval. So presumably this car is going to keep accelerating, right? It's going to keep accelerating, and we want to know what is its speed afterwards, v at the end. If this was a question from the last section, we would do this. We would say delta x, delta t, v naught, va, and we would plug in what we know. What we know is initially it's at 5 meters per second. What else do we know? The time that the force is applied for is 4 seconds. And we don't know anything else. But we want this. Now, as you know, you need 3 pieces of information. So this is where this idea comes in. You can use the dynamics information, because they tell us stuff about forces, to find acceleration, and then plug that back in here. So we're going to start off looking at the free body diagrams. So this was a bit of a dead end, but just because we were able to figure out what we need from that. F net equals ma. Ma equals the sum of the forces. Now, the sum of the forces in this case is simple. It's just Fa, right? There's only one force. It's 2. So we can figure out A quite simply because it's just 2 newtons divided by 1 meters per second squared. My acceleration is just 2 meters per second squared. And now what I'm going to do is take that information and plug it in here. So I can say 2 meters per second squared in there. So now I have that information, and now I have 3 things. This is my don't know, don't care, and then I want to find v. You're going to have to pull out your 5 equations from before. I'm sure it's online somewhere in one of the Google Drives, Google folders. But the equation without delta t is v equals v naught plus a delta t. So that's already set up to be solved. So it's 5 plus, and we've got 2 times 4. So we've got 5 plus 8, and that equals 13 meters per second squared. The question is, what's the velocity? So the velocity is, oops, not squared, just meters per second, meters per second. Oh, it's something meters, 13 meters per second. Okay, and that's how you solve this question.